Hi, welcome to chapter 2 on kinematics. This is for your O level and N level science physics and physics. Okay, these are the objectives that we're going to cover today in this lesson. Okay, you can pause the video anytime now to just take a look at it. Okay, let's start. In terms of the difference between scalar and vector, the thing that we need to know is that for scalar, it is only the magnitude. Okay, scalar is only the magnitude. So right, what you're only looking at, right, is the number that we have for it. For example, 10 kg, 20 kg, 20 meter per second. Those are scalar only because there is only a number towards it. However, for vector, it has direction and magnitude. This is something that we need to know. The only difference down here is that there is something called direction. So the direction is like, for example, I am moving at 20 meter per second towards the east direction. That is your velocity. Okay, those are vectors. So the difference between scalar and vectors are, like, for example, distance. We link them to displacement. So the scalar quantity down here is distance, and the vector quantity is called displacement. For speed, scalar being a speed is a scalar. It has no direction. So, like, for example, how do we measure speed? Like, for example, your speedometer on your car, when you go reverse or when you go forward, they both just give you a certain value. That is your speed. But for velocity, it has a direction towards it. The scalar quantity is mass, and the vector quantity of mass is weight. Okay, so right, weight is always pointing downward, but your mass is just an arbitrary number that we give when you're at different parts of in space or in whatever location that you are. Time is a scalar quantity, but there is no vector quantity of time. Okay, a vector quantity is also like acceleration. Okay, am I accelerating forward, to the left, to the right? Those are the things that we need to say also. We need to have a direction component. Okay, so first of all, we need to explain what's the difference between displacement and distance. Okay, displacement is the straight line distance from the start to the end. So if I, for example, I have A, I have B, I move in this direction, the scalar quantity is actually a straight line across. Okay, so all this direction down here that we have, for example, in example 1, the boy moved 40 meter east, 30 meter to the north, 40 meter west, and 30 meter to the south. Those are all your displacement. Okay, so how we do it is that we have a boy, we walk 40 meter to the east, 30 meter north, 40 meter west, and 30 meter down. Okay, you must see that the distance that he moved is actually like this. Okay, he has moved quite a large distance. So therefore the distance, right, is just adding the individual component, which is first part, the second part, the third part, and the fourth part. So therefore it is 40 plus 30 plus 40 plus 30. 140 meter is your total distance. But for displacement, it's slightly different. We must know where is the start. The start is here, the end is here. So because they are at the exact same point, there is no displacement because of there's no distance between the start point and end point. They start and end at the same part. So it is 0 meter is because the start and end point are the same. Moving on to speed and velocity. Okay, speed is the rate of change of distance per unit time. Okay, distance down here is a scalar quantity. Time is also a scalar quantity. So because scalar and scalar, you get a scalar quantity. So therefore speed is a scalar quantity. Okay, the definition of instantaneous speed means is the speed at the exact time in point in time. Okay, this one is something that I think is quite understandable, which is instantaneous. Okay, velocity is different. Okay, this is something that you are learning in your O level and N level syllabus, is that it is the rate of change of displacement per unit time. Okay, it's very similar to speed, it's just that velocity has a direction component. Displacement, as what we mentioned already, it has a start point and an end point. There is a direction towards it. It is a vector quantity. Vector divided by scalar, because of the vector component, it gives you a vector quantity. velocity is a vector quantity. Okay, moving on. Okay, average speed is just total distance divided by total time. This one you have learned in primary school. Okay, average velocity, this is something that's different, is total displacement over total time. Okay, units for velocity and speed, they are the same, meter per second, no change. Okay, if I have something that is positive velocity, it means I am moving forward. For example, I'm driving a car, I'm moving forward, that's a positive velocity. Okay, my speed is still positive. Okay, speed will always be positive. But if, for example, I'm reversing, I'm going in the other direction, my speed is still positive, but my velocity is negative because I am moving backwards. Okay, the units for speed and velocity is the same, meter per second, as mentioned before. Okay, for example, if I have an MRT that takes 25 minutes to travel 15 kilometer, first of all, we need to take the note, right, is that minutes down here is not SI unit. Okay, we need to change it to seconds. Okay, so in order for us to change to seconds, it is 25 minutes times 60 seconds gives you 1500 seconds. Okay, so from here I know that I can calculate my average speed. Average speed formula is this, we have mentioned before, average speed equal total distance divided by total time. 15 km is 15,000 meter, so therefore 15,000 meter divided by 1500, it gives me 10 meter per second. Okay, in terms of conversion, you can take a look at this working. So what I would like you all to do first, right, is to convert your meter to kilometer, then multiply it by 3,600 seconds. Okay, a ticker tape is something that is hardly coming out in the syllabus, but I think it's important for us to know that how we view it. Okay, if an object has equal distance, okay, at the first second I am here, my second second I'm here, third second I am here, fourth second I'm here, fifth second, sixth second, you can see that the distance in between each other, they are all equal. And because we know that speed equal to distance over time, okay, the change in distance divided by in time, right, is the same. So therefore we know that this whole area down here, it is moving with constant speed. However, if I realize that the next one down here, I have a small gap here, but I have a very large gap here, the distance has increased per unit time. So therefore, it tells me that there is increasing speed. But in the other case, whereby there's a large distance here and a small distance here, we know that the distance has decreased. So because the distance has decreased, it means that it's moving at decreasing speed. Okay. So right, for example 3, it's mainly telling you with regards to a vibrating arm that is making 50 dots per second, and then the distance in between each other. Okay, if there is 50 dots in 1 second, okay, 1 dot takes 1/50 seconds. Okay, seconds. Okay, so therefore it means that we need to count the number of dots. 1 dot making 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 dots in total. So therefore 10 dots means there are 10 intervals. And we know that one interval is 0.02 seconds. You have 10 intervals. It means that the total time taken to travel 20 cm is 0.2 seconds. And we also need to convert the 20 centimeter into meter. It gives us 0.2 over 0.2. It gives us 1 meter per second. The reason why we're able to do this is because speed is equal to distance over time. So that's how we are able to calculate the speed of the ticker tape. This is just another example in terms of how we did it. It's the same exact method. We calculate the 60 dots per second. We are able to find that 12 intervals gives us 0.2 second. 0.2 second is the total time. The distance is 48 cm. So therefore distance divided by time, it gives me the speed. Acceleration is the rate of change of velocity per unit time. Okay, so the thing is that, like for example, if I'm going to press the accelerator of my pedal, my speed will just increase and increase and increase and increase. Okay, the formula that we need to know that is that A equal to V minus U over T. Okay, let me explain in terms of what is A, V, U, and T. A is your acceleration, the units is meter per second squared. Okay, V is your final velocity, the unit is meter per second because the unit for speed and velocity is meter per second. Your initial velocity is represented by a letter U, unit same, meter per second. Time, I don't need to explain much, is the unit is second. So therefore the SI unit for acceleration is meter per second squared. Okay, because the thing is that is meter per second at the numerator divided by second, it gives me meter per second squared. Okay, the direction of the acceleration, right, is actually also equal to the direction of force, which we'll cover in chapter 3 on forces and dynamics. Okay, deceleration. Okay, when I'm driving a car that time, when I press on the accelerator, it's the right pedal. When I press on the brake, I am actually decelerating the car. So right, deceleration, another word for deceleration is actually called retardation. Okay, the force is retardating on me. I am going slower and slower and slower. Okay, the formula that links deceleration and acceleration, you just need to put one negative sign. So we know that acceleration is equal to negative deceleration. That's just mainly it. So example 4, if I'm going to start, the keyword is start. Start means I'm starting from rest. It means that my initial velocity is 0 meter per second. And I reach, the word reach is very important, reach a velocity of 20 meters per second. It means that that is my final velocity. Okay, my final velocity is 25 meter per second. And the time that it takes is just 5 seconds. Okay, so we'll just plug and play the formula. They ask us to calculate average acceleration, which is the letter A. We know that the final velocity V is 25 meter per second. The initial velocity U is rest because it is starting from 0 meter per second. And the total time down here is just 5 seconds. So therefore, we plug and play the value. A equal to V minus U over T is 25 minus 0 over 5. It gives us 5 meter per second squared. Whereas for example 5, we are going to talk about the word brake. When I think of brake, we must always think of the word deceleration. My car is going slower and slower and slower. And when I was initially traveling at 40 meter per second, this is my initial velocity. The total time they give me is 4 seconds. And then they say the velocity of the car is reduced to 10 meter per second. That means it's afterwards. After 4 seconds, it reduced to 10 meter per second. It means that 10 meter per second is my final velocity. So therefore, using the formula A equal to V minus U over T, my final velocity is 10 meter per second. My initial velocity is 40 meter per second because it's mentioned here. And the time taken is just 4 seconds. So therefore, I'm able to find my acceleration value of negative 7.5 meter per second squared. And because we know that deceleration is negative acceleration, the deceleration value is just the negative of negative 7.5, gives us 7.5 meter per second squared. Example 6, the car starts from rest. The rest means U is 0, so therefore U is equal to 0 meter per second. And it accelerates at it accelerates at 5 meter per second squared. So therefore 5 meter per second squared is my acceleration value. They ask us to find the value of time. This is the unknown that we do not know. Okay, and it reaches a velocity of 30 meter per second. The word reach means that this 30 meter per second is your final velocity. I plug and play. The only unknown that I do not know is this time variable down here. So A equal V minus U over T. I plug and play my values. Acceleration value 5 because this is the acceleration value that they gave us. The final velocity is 30 because the question states down here 30 meter per second. Initial velocity, they mention down here from rest, so therefore it is 0. Time is the variable that we do not know. So therefore, by simple mathematical manipulation, we're able to get time equal to 6 seconds. Okay, so example 7 is one whereby a car is moving down a straight road and has an acceleration value of 4 meter per second squared. It reaches a final velocity of 60 meter per second. So this is your final velocity. Time taken is 5 seconds. So we do not know this initial velocity down here. We plug and play the value. Acceleration is 4 meter per second. Final velocity is 60 meter per second. U is our unknown that we do not know. Time is 5 seconds. We plug and play here. So therefore, by simple mathematical manipulation, we can find that the initial velocity is 40 meter per second. Okay, moving on, we're going to cover the distance time graph. Okay, the distance time graph, right, whenever we see such a graph question, right, the first thing first that we need to do is always identify what kind of graph is this. Okay, the distance time graph, the y-axis down here, they will indicate that it is distance, and the x-axis down here, they will indicate that it is time. Okay, for distance time graph, the main important thing that we need to know is that we need to identify the gradient. Okay, what do we mean by gradient? Okay, gradient means how steep the graph is. Okay, for example, if I have like a graph that is this steep versus something that is this steep, okay, I will realize that the top one is more steep. So right, this is more steep, and this is less steep. Okay, when I mean that something that is more steep, right, the graph is steeper, it means that it has a higher speed. Whereas something that is less steep, it means that it has something that has a lesser speed. So the gradient of the distance time graph will represent the speed of the moving object. Okay, let's dive into the first part. Okay, when an object is at rest, that means not moving or like not even moving at all. Okay, the distance will always be the same. So for example, if I am not moving, I am standing at distance 0. After 1 second later, so 0 second, I'm not moving, 0 is at distance 0. After 1 second, I am still at 0. 2 seconds later, still at 0. 3 seconds later, still at 0. 4 seconds, 5 seconds, all still at 0. So when we draw a line across like this, the line is actually a horizontal line, okay, and the gradient is 0. And another example whereby we have a gradient whereby it is 0 is like, for example, I am standing at 30 meter per second, at 30 meter at the time 0. After 2 seconds, after 1 second, 2 seconds, 3 seconds, all the way until the 5 seconds, I am still at the 30 meter mark because I did not move. Okay, from here, when you see something that is a horizontal line for a distant time graph and the gradient is 0, it means that the speed is 0. Okay, when speed is 0, right, it means that the object is not moving or stationary. Okay, so when we want to explain in terms of question, right, like identify the speed of the object, okay, we must first of all say that the gradient of the graph is 0, and because this is a distant time graph, the speed is being represented by the gradient, and therefore the object is not moving or stationary. Okay, for those students that do not know how to spell the word stationary, right, can you please use the word not moving? Because if you spell stationary wrongly in your exams, right, the examiner might mark you down. Okay, one common mistake that students make is that they spell stationary as stationaries, okay, like your pen and ruler, that kind of stuff. Those are the things that we do not want you to spell wrongly. So just use the word not moving if you feel uncomfortable. Okay, when an object is moving at a constant speed, okay, like for example, I am moving at 10 meter per second. At time 0, I am at 0. After 1 second later, I will have moved 10 meter. After 2 seconds, I will have moved another 10 meter, which brings me up to the 20 meter mark. And then it keeps increasing at 10 meter increment per second. So therefore, the gradient down here, this 10 meter per second, it gives you the speed at which the object is moving. So an object whereby it's moving even at faster, like for example, I am moving at 20 meter per second. At time 0, I am at 0. 1 second later, I am at a 20 meter mark. 2 seconds later, I am at the 40 meter mark because I increase by 20 meter every second. So from this, we can see that the gradient of the graph is always a positive constant when I'm moving at uniform or constant speed. So therefore, the gradient of the graph represents the speed. This is a very standard thing that we need to always mention for a distant time graph. And we can say that our object is moving with constant positive speed, okay? Or constant speed. When an object is increasing in speed, right, it means, right, that the graph gradient, you can take a look down here, this is not so steep, down here becomes steeper because with acceleration, your speed gets faster and faster and faster. And then the gradient will get steeper and steeper and steeper because the gradient of the distant time graph represents the speed. So because of this, we can see that the gradient is increasing like this, okay? That means the gradient is increasing when we know that the linkage between gradient and speed is exactly the same. So therefore, as the gradient of the graph increases, it means that the speed of the object increases. So therefore, you can say the object is moving with increasing speed or is accelerating. If, for example, a graph whereby the object is moving with decreasing speed, okay, it means that the gradient, you can see down here, is very steep, but whereas down here it is less steep. Okay, that means the graph is curving like this. Okay, so that means, right, that the gradient is decreasing, and we also know that again that gradient means speed. So therefore, the object is moving with decreasing speed, or we can say that the object is decelerating. Okay, let's take a look at this example down here. Okay, we realize that from point A to point B down here, the gradient is increasing. So we are able to identify that the gradient is increasing, and since we know that the gradient of a distant time graph represents speed, so therefore the object is accelerating. When we have one straight line down here from B to C, it means that the gradient down here is a constant positive. So therefore, we are able to say that the speed is a constant positive value. But whereas for parts C and D down here, the gradient is actually a horizontal line. Horizontal line means gradient is 0. So therefore, we know that the speed is 0 meter per second. And 0 meter per second means that we are not moving. Okay, so they ask you in terms of like, describe the motion of the object between point A and B. We have already mentioned down here in the graph that since the gradient is increasing, it means that the object is moving with increasing speed or is accelerating. Okay, and if they ask you to explain why the object motion is increasing with acceleration, you just need to say that the gradient of the distant time graph represents speed. This is how we have mentioned previously in our lecture. Okay, and since the gradient is increasing, it means that the object is accelerating. Okay, so they ask you down here, calculate the speed of the object between B and C. Okay, all you need to use is the gradient formula. So we want to find the gradient down here. Okay, we have learned in mathematics of the formula y equal to, gradient is equal to y2 minus y1 over x2 minus x1. Okay, so from here we're able to find that the final distance down here is 25 meter per second, and the time is 15. And at point B down here, the distance down here is 10 meter, and the time is 5 seconds. So therefore, we need to find the total distance traveled. The total distance traveled will just be 25 minus 10. We have moved 15 meter, which is why I have mentioned it down here, 15 meter. And the total time that we take is the time interval between here and here. It is between the 5 second mark and the 15 second mark. So therefore, 10 seconds has passed. So therefore, this 10 represents the distance, the time between this part. Okay, we apply the formula speed equal distance over time, we get 1.5 meter per second. The next question asks you, what is the distance traveled in the object in the last 10 seconds? Okay, we'll go back to the graph. They ask you for the last 10 seconds. The last 10 seconds will represent this portion down here. This is your last 10 seconds. Okay, we realize and we know from the graph is that it is a horizontal line, and horizontal line means gradient equals 0. Gradient equals 0 means speed equal to 0. Therefore, the distance traveled is 0 meter. So they ask you calculate the average speed of the object during the first 15 seconds. We know that average speed is equal to total distance divided by total time. The first 15 seconds, we are looking at only this portion down here. Okay, the total distance that we travel is just down here at the 25-meter mark, and the total time is just 15 seconds. So therefore, you plug and play the formula: average speed equal total distance divided by total time. Total distance, total time, 25 over 15, it will give you 1.67 meter per second. Okay, up next we're going to talk about the speed time graph. Okay, speed time graph and distance time graph are very different, mainly because of this. The y-axis down here, it indicates speed. Okay, previously we have talked about distance, so now we're going to talk about speed time graph. A speed time graph. Okay, the gradient of the speed time graph represents the acceleration of the moving object. Okay, this is very important. And the area under the speed time graph represents the distance traveled by the moving object. The reason for this is because it's the integral of the speed time graph. The distance is equal to the integral of a speed time graph. Okay, you'll learn this more in JC and Poly regarding this. Okay, when an object is at rest, okay, at rest, I am not moving at all. We have learned that for if I'm not moving at all, my speed is 0 meter per second, right? At time, I don't even change my speed at all. So when I'm not moving at all, when I'm at rest, my distance will always be at the my speed will always be at the 0 meter per second. The reason why is because I am not moving. Okay, next up, if I am moving with constant speed, okay, if I'm moving with constant speed, it means that my acceleration value is 0. Okay, because if I use the formula a equal to v minus u over t, my final speed and my initial speed, this part down here, will always be equal to 0 because my acceleration value is 0. I'm moving at constant speed. So from the speed time graph here, right, we can see, right, that any value, there will be values here, here, anywhere in the middle. Okay, it means that I'm moving at constant speed, but the thing is that it must be a horizontal line. Okay, and the gradient will always be equal to 0 if I'm moving at constant speed because there is no acceleration value. Okay, and we know as the gradient of a speed time graph, the gradient is here, horizontal line. It means that the acceleration value is 0 and the object is moving at constant speed or no acceleration. But I would prefer you all to use the word constant speed. Okay, and the area under the graph, for example, I'm going to take a look at this big area down here. Okay, the area under the graph of this 20 meter per second is actually equal to 20 meter times 5 seconds. Therefore, it gives me the area on the graph 100 meter. Okay, and since the area under the graph gives the distance traveled by the object, this area down here, it gives us the distance traveled by the object. So therefore, we have calculated already that the area under the graph is 100 meter. So therefore, the distance traveled by the object is 100 meter. Okay. Now, this is the part whereby it gets a bit more tricky. I'm moving on with constant acceleration. So if I am traveling at 0 meter per second, at time equals 0, I accelerate at 5 meter per second. Okay, at 1 second, my speed will be 5 meter per second. I accelerate again. At 2 seconds, my speed will be 10 meter per second. 3 seconds, it will be 15 meter. 4 seconds, it will be 20 meter per second. 5 seconds, it will be 25 meter per second. So therefore, when we link all the points up, we can see there is a one straight line down here, but it is not horizontal. Okay, there is a value to the gradient, and the gradient down here that we know is 5 meter per second. Okay, this is a constant positive value, so therefore the gradient means that there is a constant acceleration value. Okay, so therefore the object is just constantly accelerating, and the area under the graph for constant acceleration speed time graph is just an area of a triangle. Okay, triangle you have learned in primary school is just half times base times height. I can see down here there is half, oops, it's just half of the base, which is 5. The base is 5, and the height is just 25. So therefore half times 25 times 5, oops, I write this wrongly, I should change it. Half times 5 times 25, you give me 62.5 meter. So therefore, since we know that the area under the graph is 62.5, it means that the object has traveled 62.5 meter, because area under the graph gives you the distance, area under the speed time graph gives you the distance traveled by the object. If I'm going to move with increasing acceleration, you can see that my speed will just increase but at a increasing rate. So therefore, you can see at part 1 down here, it is not very steep. But at part 2 down here, it is much steeper. So the gradient is constantly increasing. And when I know that the gradient of a speed time graph is equal to the acceleration value, it means that the object is increasingly accelerating. So therefore it gets faster and faster and faster. Whereas for deceleration value, you can see that the gradient down here, part 1, it is very steep. Part 2 down here, it is not so steep. So therefore, we learn again that the gradient of a speed time graph is decreasing. It means that the acceleration value is decreasing. So therefore, the object is undergoing decreasing acceleration. Okay, it gets faster but just at a slower rate. Okay, constant deceleration, this is one whereby I press the brakes of my car. Okay, when I press the brakes of my car, right, the speeds get slower and slower and slower. Okay, so therefore the gradient is a constant negative value. It's going downwards. Okay, if it's going downwards, it means that the acceleration value is a negative value. And we have learned that negative acceleration is equal to deceleration. So therefore, the object, we know that it is undergoing constant deceleration. And the area under the graph, as I mentioned before, is just the distance traveled. Distance traveled is just the area under the graph. This area down here is just 62.5 because it's half times 5 times 25. Okay, so therefore the distance traveled is 62.5 meter. I will not dwell much into the question down here. Okay, but the first thing that we need to know is always identify the graph. This is a speed time graph. And we know that for part A down here, from 0 to P down here, this is a constant acceleration. Okay, it is a constant acceleration. Okay, and if I'm going at 300 meter per second down here and the line is horizontal, this means that this is a constant speed. Okay, sorry for my handwriting. Okay, and for the last portion down here, going downwards, and we know that the gradient is negative, so therefore down here, this portion down here is a constant deceleration. Okay, it is a constant deceleration. The question asks you to identify the distance traveled within the first 2 seconds. We identify it as this portion down here. Okay, this is a trapezium. I honestly don't like to memorize the trapezium formula. So for you, you just need to memorize that it's the area under the graph, and I like you to break it up into 2 parts. Okay, the first part is a triangle. I represented it by a letter A. For letter A, we know that the base is 1, the height is 300. So therefore, it is half times 300 times 1. This gives me the area of the triangle A. Next part, they ask you for the second, so therefore we need to mention this part also. This part down here is just a regular rectangle. It's just 1 times 300. So therefore 300 times 1. So therefore the total distance is just 450 meter because area under the graph. Okay, so what does line PQ indicate about the motion of the car? Okay, let's focus on PQ. we must take a look at this. This is a horizontal line. Horizontal line means that the gradient is 0. So therefore, we first of all identify that the gradient is 0. If gradient of a speed time graph represents acceleration and the gradient is 0, therefore, we know that the acceleration value is 0 meter per second square. If I know that it is moving at 0 meter, it's accelerating at 0 meter per second square, it means that my speed is at, I don't increase my speed, I don't decrease my speed, so therefore the object is moving with constant speed. Okay, for the next part, they ask you to find what's the acceleration value for the deceleration component, which is the last 2 seconds, which is this component down here. Okay, you just need to plug and play the formula. We know that the acceleration value is a equal to v minus u over t. V in this case is my final velocity. So therefore v gives me 0. My final velocity is 0. My initial velocity is 300. Okay, it's at the part down here whereby they tell me that's my initial speed, 300 meter per second. After which we plug in the value 300 down here. So it's 0 minus 300. The time taken is just the total time that we take to decelerate from 300 meter per second to 0 meter per second. It gives me 2, because 5 minus 3 is 2. So therefore, plug and play your value, you'll realize that the acceleration value in this case is negative 150 meter per second square. And knowing that acceleration value, the deceleration value is equal to the negative of acceleration value, you just remove the negative sign. So therefore, it becomes 150 meter per second square, because it's negative 150 meter per second square. So therefore, it gives me 150 meter per second square. Let's take a look at object. Example 10. Okay. My speed down here is 0, so therefore it tells me that it is not moving. Okay. This line down here, BC, is a straight line that is pointing upwards. The gradient is a positive value, and the gradient does not change. So therefore it tells me that it is moving with constant acceleration. The line CD down here, the gradient is 0. Okay, that means there is no acceleration, but because there is a speed here of 40 meter per second, it indicates to me that it is moving with a constant speed. It does not change its speed, but it's just moving, as compared to this portion down here whereby it is not moving. Okay, line DE down here is pointing downwards. Okay, the gradient is negative. So as we know that the gradient of a speed time graph is acceleration, the acceleration down here is negative. And negative of negative acceleration, it tells me that there is constant deceleration. Okay. EF is the same as AB. It is not moving. Okay. And BC compared to FG, we know that they are both with constant acceleration. It's just that the constant acceleration value of BC is larger than that of FG because BC is steeper. Okay. So the next part, I skip part A to part C, but let's focus on part D. They ask you to find the retardation. Okay, it's quite common that the question asks you what's the retardation between whatever time. So between 4 and 6 seconds, we know that this is a deceleration. Deceleration is actually equal to retardation. So first step is that we find the acceleration value. The acceleration value, we plug and play. It is just a equal to v minus u over t. The final velocity in this case is this portion down here, which is 0, minus the initial value, which is down here 40, over the time taken, which is 2, which gives me negative 20 meter per second square. And since I know that it is negative 20 meter per second, the acceleration value is negative 20 meter per second square, and I know that deceleration value is equal to negative of acceleration, the negative of negative gives me a positive 20 meter per second. That's my deceleration value or my retardation value. Okay, and log on to the last part with regards on the topic of kinematics. Okay, mainly we need to talk about the free fall due to the Earth gravitational pull. Sorry. So whenever you throw something out of the wind, okay, not asking you to throw something out the window, but if you release something out from height, it actually falls down to the Earth, and the acceleration value of it is actually 10 meter per second square, assuming idealistic state. Okay. When an object is allowed to free fall from under the Earth gravitational pull, it actually speeds up. Okay, it gets faster and faster and faster. So, like for example, if you see your space shuttle falling onto Earth, it actually gets faster and faster and faster, with a constant acceleration value. But those space shuttles are able to slow down. Okay, so right, why we fall why it accelerates down to the Earth's surface is because it actually accelerates due to the Earth's gravity, because of the body being a large massive body actually causes a gravitational pull, and that's why all objects are usually remain rooted onto the Earth's surface. Okay, we need to memorize this value of 10 meter per second square. This is the acceleration due to free fall on Earth only. Okay, and this is assuming that there is no air resistance. Okay, if there is no air resistance, the speed will always be assumed to have an acceleration value of 10 meter per second square. Okay, so right, if a mass, for example 11, a mass falls 2.5 kg from rest, okay, we need to know that there's a constant acceleration value of 10 meter per second. Okay, the very common mistake that students have, right, is C and D, okay, whereby they say that C and D, whereby they think that, oh, there is a constant velocity, but when you fall down to Earth, it's always at a constant acceleration value. So therefore answer is A. Okay, I will skip the rest of the question and I'll go on to the summary. Okay, so in terms of recap, we need to know that speed is a scalar, distance is a scalar, time is a scalar, so therefore speed is also a scalar. Velocity is a vector, displacement, the reason why velocity is a vector is because displacement is a vector, but time is the scalar. So vector over scalar, it gives me a vector. Okay, the formula that we need to memorize down here is acceleration equal to the acceleration value is equal to v minus u over t, and that deceleration is equal to the negative of acceleration. Then for the speed time graph, okay, speed time graph, if I have it at the bottom down here, it is not moving. If I have it with a constant gradient like that, it is a constant acceleration value. All these red color parts down here, they are all constant speed because the speed the gradient is 0, but yet they have speed, so therefore they are constant speed. When the gradient increases like this, it means that there is increasing acceleration. When it's increasing like this, it means that there's increasing acceleration. But when it curves downwards, it means there's a decreasing acceleration. And if it points downwards, it means that there is a constant deceleration. Okay, and the area under the speed time graph will give you the distance traveled by the object. Whereas for the distance time graph, object, and object, they are all not moving. And because down here the gradient is constant and positive, it is moving with a constant speed, because the gradient of a distance time graph is the speed. If the gradient is increasing, it means that there is increasing speed, so therefore it means that the object is accelerating. But if the gradient is decreasing, it means that the speed is decreasing, so therefore it is of a decreasing speed. So that's it for chapter 2.